Hi everyone, my name is Dylan Lucia, and I'm going to be teaching you how to use generative design in Fusion 360, which is offered for free by Autodesk with an education account. And so I have Fusion open right now, but in case you don't have it, the very first thing that you're going to need to do is go to autodesk.com/education. And here you're going to sign up for an account, which is up here. I'm currently logged in, but you're going to click here and click sign up. And when you sign up for that account, it's really important that you select your educational role as a student or an educator, depending on which one is correct. And then you can go ahead and confirm your eligibility. For me, I had to send them a photo of my student ID. Sometimes it's just based off of your two-lane email alone, but it depends on, who knows, whatever factors it may be. And once you've done that, then you should have access to the free software from Autodesk. And they offer almost all of their software for free with a university account, and you just have to kind of renew it each year. And so it'll keep going. It used to last for 3 years, but currently it lasts for 1 year. So it changes because this is a cloud-based software package. So when you're on autodesk.com/education, make sure you're signed in, and you're going to click this button that says Get Products. And here is where you are going to download the software for free. And so you can see right here, my educational access is good until June 30th, 2021, in which case I'll need to re-verify my eligibility. But we are going to go ahead and click on this Fusion 360 section. We're going to go ahead and click on Get Product. And when you do that, it's going to download an installer. You may have to do some verification things. It may send you an email with a key. But Fusion is usually pretty automatic and doesn't really need that. That's more for something like AutoCAD, which isn't as cloud-based. But because Fusion is cloud-based and it keeps itself updated, once you install this, you're never going to have to install an updater or anything like that. It is completely like hands off, it's autopilot. It's really easy to use. So we're going to go ahead and jump into Fusion. And when you first open Fusion, you may have to sign in, and you're going to use that same educational account that you created on the web to sign into Fusion. And the reason why is because that is how you will gain access to the software for free. So you have to download the installer from your education account, and then you have to log into Fusion with your educational account. But once you are logged in, you should be welcomed to a page like this. This is just the blank workspace. And in case you haven't used Fusion, it's pretty similar to SolidWorks. It is a CAD software, so it's computer-aided design, and you can do a lot of stuff that is kind of built in. And so that can be extensions with manufacturing, so you can do CNC work in the makerspace. You can do simulations, you can do impact simulations. There's a lot of stuff you can do with Fusion, and it is updated at least once a week. Half the time when I log in, there's a little green bar that says, you know, you are updated to the latest version of Fusion. It does it all in the background. It's really easy. In case you aren't logged in, or if you're on a shared computer, you can go up to this button at the top right, and that is where you can sign out and then sign into your correct account. And also preferences are from that button as well. This is where you can set things like your default modeling orientation, the type of orbit you like, your shortcuts, anything like that. But just in case you need those, that's where you'll find them. So what we're going to do is we're going to create a crank with generative design. And generative design is really interesting because it uses reiterations of AI software to create a model. And so the way that it does that is it uses constraints and preserve geometries, and those geometries and obstacle geometries. And those are how you define what you want to keep in it and what you don't want it to kind of grow into. You can kind of think of it like vines creeping along. And they're going to grow and create a path that is both strong and lightweight, and you're preserving materials, and you can change it based off of the material type you're using. You can put different types of loads on it. There's a lot you can do, and we're going to be exploring all of that. But the most important thing about it is that it is unpredictable. And so that is why we are going to be very careful when we're setting it up, because you can get results that you are not expecting, but technically may be correct, but they aren't exactly what you want. So the very first thing we're going to do is just create some bodies in Fusion, which are going to be our obstacle and preserve geometries. And basically what that means is we're going to create the stuff that we tell the AI, I want this kind of form to be in the final generative design, or I do not want it to go into this area for whatever reason. And so that reason for obstacle geometry could be, I want to keep this hole clear, so I don't want anything to grow into it. I want to keep this area clear so that way it can interface with something, whatever it may be. It all depends on your design. And so we're going to be creating a simple square drive crank. And this is completely arbitrary, it's not being used for anything, but this crank is something that we are going to just define the bare minimum of, essentially. And then we're going to let the generative design do its thing, and then it's going to create this kind of finished product for us. And so the first thing we're going to do is we're going to open up our data panel with this button, and this is where you're going to see all your different projects. And so you're going to go ahead and click this blue new project button, and you're going to type in a name for this. So it could be generative design tutorial, it could be a class name, it could be whatever you really want. But since I already have a generative design tutorial, I'm going to go ahead and go into there. I'm going to close that panel so we're inside there, and then I'm going to hit this button and new design. And realistically, we don't have to do that because we already had that tab open, but it's just in case like you accidentally clicked any buttons, whatever it may be. So we are looking at our blank workspace, and in this area you can see the kind of grid, the layout grid. If you don't see it, you can go down to here, which is grid and shapes button, and you can turn on the layout grid with this check mark. I like to have it on when I'm starting at the beginning. I might turn it off later, but I like to start with it because otherwise, when I'm just looking at it like this, I cannot figure out what I'm looking at. It's just blank. And so this layout grid like that lets me orbit around and get some sense of where I am in space. And we're going to use the free orbit cube up here to return to our home view, which is just a nice isometric view. So if you are orbiting and you're not exactly sure why it's like getting all spinny or anything like that, that may be because you have, see like this is getting all angled, that may be because you have the constrained orbit off or on. And so we're going to go ahead and switch that to constrained orbit, and we're going to go back to our home. And now as I'm orbiting around, you can see it kind of keeps a vertical almost. And so that's just for, I guess, sanity. But once I turn off the grid, usually later in design, I might turn off that constrained orbit, so that way it's a little bit more freeform and I can get to like places that I want to really easily. Just some things to keep in mind. So the very first thing we're going to do is we're going to define a sketch, just like in any CAD software. And so to do that, we're going to go up to the ribbon at the top here, and we're going to click the new sketch button. And we're going to do this on the top plane. And we are going to create basically the crank interface. As I said before, this is a square drive crank. And so we're going to create basically that square drive. So we're going to click on this top plane right here, and you can see that coordinates right there with the top. And so now we're looking at the origin of the top right here. And the very first thing I'm going to do is I'm going to create a square, because this is a square drive crank. But I don't want to do a 2-point rectangle because that's going to be defined by 2 outer edges. Instead, I'm going to do a center. And so we're going to click on the create dropdown, go down to rectangle, and do center rectangle. And so now if we just hover, you can see it gives a tooltip which says place center point. So we're going to go ahead and click on the origin right there. And we're just going to type in the dimensions that we want. However, what we're going to define this as is, we're going to imagine that this is being milled from, let's say, some 10mm stock. And so some round stock like that is 10mm in diameter. We don't exactly know what that diameter is based off of the height and width of the square. So we're just going to click arbitrarily. And then what we're going to do is create a circle from the center point circle tool, which is just the default right there. And this is where we're going to define that 10mm diameter. So let's go ahead and let's just type in 10, okay? And so now we want this square to kind of fit inside that circle. We want it to be inscribed in it. So what we're going to do is just drag one of those corners so it kind of fits in there. And then all we need to do is click on this point, we're going to click coincident and click the circle, like that. And then we're going to do it with this one as well. And actually, that's over constraining, so we're not going to do that. But what we are going to do is you can see that this isn't even. It's not defined as a square. So while, yes, the point is constrained to the outside of the circle, it's not considered a square. It's still a rectangle. So to do that, we're going to get an equal constraint, and we're going to click on the top and left edges of that rectangle, and now it is constrained as a square. And you know it's fully constrained because it's now black, and if we try and drag on it, it doesn't move because it's locked. So we're going to go ahead and finish this sketch. And now that we've finished it, we can check in the sketch panel, and you can see it has a little lock icon right next to it. That means it is fully constrained. So that is a locked drawing. It's not going to just randomly change or confuse us, anything like that. Let's go ahead and let's go back to home. And so you can see this is our isometric view. And what we're going to do is we are going to extrude, and so you can either click this button, or you can click E, or you can click Q, which is the press pull tool, which is kind of an all-purpose tool. It doesn't really matter. So I'm going to hit E on my keyboard, and I'm going to hover over the square. You can see we can hover over some of these like kind of semi-lunar areas, but we're going to hover over the square, and we are going to extrude this by 10 millimeters. And we are setting this operation to new body, and we're going to hit OK. And let's go ahead, let's zoom out, and let's orbit around. You can see we have extruded this up 10 millimeters. And so now let's go ahead and let's drop open our bodies in the tree over here, and let's rename this, because this is the start of our square drive. So let's rename this square drive, so we can keep track of it. Okay, so we've got our square drive. And now we are going to create a revolve. And this is kind of the plate that the crank itself is going to attach to. So it's the crank arm is what we are going to use in the generative design. We are defining this preserved geometry, which is the kind of the plate that will interface, and it has that square drive, and then it's also where we're going to bolt the arm for the radius of our crank. And so let's go ahead and let's go to the create sketch, and we're going to create that plate on top of this square drive. And so we're going to do that from the front plane. So we can see that that's this plane, which right now as we're hovering, you can see it's highlighting this plane of the body we created. So if you click and hold, you can say, I want XY. And so now we're creating a sketch on the XY, which is the front plane right here, XY front. So we're creating a sketch on the front plane, and the first thing we're going to do is, remember we're creating this from round stock, and we're kind of squaring off the end of the round stock. And that may be something that's just given to us, like, you know, a supervisor says, like, this is where it's going to be interfacing with whatever machine we're making, who knows. But they're defining it as kind of a 10 millimeter round stock. And so what we're going to do, we already defined that circle as 10 millimeters, and so we're going to kind of recreate that in this sketch plane. And so to easily do that, we're going to project one of these edges in here. So we're going to hit P on our keyboard, or alternatively go to the Create dropdown, come down to Project Include, and hit Project. And we're going to click that edge. And we're going to create a projection link, which means that it's going to continuously keep that there. And we're going to hit OK. And so now you can see we've got this kind of purple line right there, and we can turn off the body if we want. And you can see that line is now in our sketch plane. Now, we're going to go ahead and create a rectangle, and we want to do this as a construction because we're just referencing this. We don't want it to get in the way of our drawing of our actual sketch bodies. And so to do that, we're going to hit X on our keyboard or click this button. So I'm going to hit X on my keyboard, and now I'm going to go ahead and create my square, which we are just going to arbitrarily start from that point and then drag it somewhere. And then we're going to use that coincident constraint to make this point coincident with that point. However, you can see it's not constrained yet because this is still orange, which means it's movable. And so to create this as a full square, we're going to go back to that equal constraint and click these two edges. And so now it's a nice square. And then we're going to go ahead and create a circle that kind of encompasses that, and because we want to grab that kind of outer edge of the circle as our round stock. So to do that, we're not going to do a center point circle. Instead, we're going to do a 3-point circle, which is just a different type of circle. It's defined by 3 points. And you can see we're still in construction mode, which is good. And we're going to define this by 3 of the points of the square. It doesn't really matter which ones. There we go. And so that is fully constrained. You can see if I try and drag on it, it won't move. And so now we know that this is kind of our edge of the round stock. And so that's where we're creating this plate out of. And so we can turn that body back on if we want visually. So now what we're going to do is we are going to connect it to this square drive. And so we're going to go ahead and hit the line tool, or L on our keyboard. And we're just going to start here, and we're going to go ahead and move out. Actually, first, sorry, let's go ahead and create what we're going to revolve this around. And so to do that, we're going to hit our line tool, and we're going to snap to the midpoint, which you can see is indicated by that little triangle that snaps next to our mouse cursor. And we're going to turn off the construction tool by hitting X, so we're drawing regular sketch lines. And we're going to click on that midpoint, and we're going to move up. And we're going to just move up an arbitrary amount. Doesn't really matter how much. And then we're going to move over to create the top face of that plate. We're going to move down. We're going to move over. We're going to move down. And then we're going to connect to this point. So you can see a lot of it's blue. It's not constrained yet. That's perfectly okay. However, this is what we are going to revolve the sketch around to create this plate. And it's going to join with that square stock to create our square drive. But we don't want this little underhang here, so we're going to go ahead and just going to click the horizontal vertical constraint and then click that line. We're going to lock it to horizontal vertical. And you can see the rest of these are locked to horizontal or vertical because they have perpendicular constraints, which were created automatically, which is great. Let's go ahead, let's define the radius of this platter, I guess is what we would call that part of it, as 25 millimeters. And so now we can just kind of click and drag on stuff and see, okay, well, we can't move this out, but we can move it up and down. We can move this point still. So let's go ahead and let's create this line as tangent to the circle. And so we're going to go ahead and create that by doing a tangent constraint by clicking this line and the circle. And so now we are tangent to the outside of that circle, which is exactly what we want. And then let's say that we're creating this with a clearance, so it's going through a plate or something like that, and the square is intersecting with whatever it's cranking. But that plate, let's say it's 8 millimeters thick, which is this height right here. So we're going to hit D on our keyboard. D is in delta for the dimension tool. Alternatively, you can click up here. And we're going to click that line, and we're going to type in 8 millimeters. Also, if you need to change your sketch or your project dimensions, you can go to this drop-down on Document Settings and click this button to change the active units to millimeters. But I'm already on millimeters, so I don't really need to worry about that. All right, so now we can go ahead and look at this sketch. We've still got this blue line, which means it's free-floating. So let's go ahead and define that, and let's say that this platter is 5 millimeters thick. So let's say that the crank's arm is going to have some probably M3 bolts or something like that that are passing through, and we want them to pass through about 5 millimeters of that plate. So we're going to go back to our dimension tool, and we're going to define this dimension as 5 millimeters. Great. So it looks like everything is fully constrained, all the lines are black, and if we try and drag on something, it's not going to move because we have properly drawn this out. So let's finish this sketch. And so now you can see it's kind of there, and you're going to understand why we did this circle as the outer constraint, because when we revolve it, that means this corner right here is going to kind of revolve around and perfectly touch that corner. And we're creating that with construction geometry, and instead of just defining it as the number that it ends up being, we're doing this in a way that it can update. And so it's kind of future-proofing our design. So like, let's say we ended up changing whatever this square was. Maybe we wanted it to be 12 millimeters or whatever we define that as. If we end up changing that in the future, then this will update automatically, which is really great. So let's go ahead and create a revolve by clicking the revolve tool. It's going to default to the last sketch we had selected, which is great. If it doesn't, you can go ahead, hover over it, and you can see it selects it all. And then our axis that we're revolving it around, you can either choose one of the lines or you can choose the y-axis in there, but we're going to just choose this line. And you can see that it's revolving this around. And so as we just take a glance at this, you can see that it's perfectly touching. And so now you can see how this kind of round stock was kind of shaved off to create that square. And we're just going to make sure this is set to join. So it's going to join this revolution with the square that we made and hit OK. So now we still have one body, and it's this whole thing. And you can see it's kind of this platter, and it's got this thread, or not this thread, this cylindrical area where it's going to be passing through a plate or something like that. You can almost think of that as like the bearing surface. And then we've got the square drive. So let's go ahead, let's look at the isometric home view. And now we need to create the holes for the bolts. So I said that it's probably going to use M3 bolts. So let's go ahead and create a sketch on the top surface here. So we're going to click the sketch tool and we're going to click this top surface. And there we go. So let's go ahead. Whoops. Oh, and also this is actually a great example. If you ever lose your kind of orthographic view or whatever you're looking at for your sketch, and it's not like one of these cardinal planes, you can click this look at button and click the face that you were looking at, and that'll fix it. So, but we happen to be doing this on the top plane, so I can just click top, which is nice. So let's go ahead and let's create the whole profiles that we're going to extrude through this plate. And so what we're going to do is let's create a center circle, and we're going to turn on the construction. And we are going to create this with a diameter of 17.5. And this is something that would be defined, or sorry, not a diameter. Or we want this to be a diameter, so we're going to do 17.5 by 2. And this is something that's going to be defined either just something that we choose arbitrarily, or maybe it's a constraint that something has been decided on, whatever it may be, but that's just what we have. And then we're going to go ahead and create this. We want these to be in a square formation like this, so we need to set a 45-degree line right there to constrain us in that. And so we're going to hit tab on our keyboard, so we're at the degree measurement, and you can see it's measuring from this line right here, so that would make this 135, but we're going to define that later. So we're just going to click and when we see the little X on the circle there, so it's arbitrary, and you can see if we drag this, that is just a line that is constrained to the outside of that circle. So let's go ahead, let's dimension this. And to do that, we're going to need a line to measure from. So we're going to hit L on our keyboard, and this one is going to be nice and horizontal. And you can see it, it grabs that horizontal constraint. You can kind of see it behind the 35 there. So let's go ahead and let's hit D on our keyboard, and we're going to click these two lines to create a 45-degree constraint. And so now we've got that 45-degree constraint. Now we can create a circle right here at this point. And so to do that, we're just going to hit C on our keyboard or click the circle tool right there, and this is from center and diameter. And this one, we're going to pretend like we forgot to turn off the construction. And so we're going to create this. We said M3, so we're going to do that with a 3mm nominal diameter. And to fix that, all you have to do is click on it and hit X, and that will switch it to a sketch line. And then we want 4 of these, so we're going to go ahead and do, we can either do 2 mirrors, and so you would have to have a line here to mirror it across, or we can do a rotational pattern. So circular pattern is right there under the create dropdown, and it's asking for our objects, and so let's go ahead and we're just going to pattern the circle, and then the center point is going to be the center point of this drawing, and we don't want 3, we want 4. However, you can see it's actually showing us that these are dotted, which means that they're going to be constrained, and I don't want to have to go click on each one to change them. So let's fix that by turning off construction first. And let's go ahead, click that circle, circular pattern, and now it's asking for our center point. We're going to click there. And let's just go ahead and change that to 4. And you can see that they're kind of vaguely shown right there. They're not fully drawn in yet because that's just the preview. If we hit OK, now we've got all 4 of those circles, which is great. So let's go ahead and finish this sketch. And so now we've got this sketch on the top surface of the drawing, or of the plate. And let's go ahead and let's extrude through. So we're going to hit E on our keyboard, and we're going to select each of those bodies. And we want to extrude this through the plate. And so let's go ahead, let's just drag it down. And remember how earlier we were talking about creating it so it's kind of future-proof? Let's say this platter got thicker than 16 millimeters, which is what we just happened to drag it through by. It's not going to cut all the way through. So let's go ahead and let's set this as a to object. And the object we're going to do is this bottom face of the plate. And you can see now they just automatically snap to the bottom edge of that plate. They're showing in red, which means they're cutting, and you can make sure they're cutting right there. We hit OK, and now we've got our holes in our plate, which is exactly what we were trying to cut. Cool, so now the next thing we're going to create is a new body. And the reason we're creating this as a new body is because it's going to be the preserve geometry, which is the geometry that we want the kind of connection point for the bolts that are going through the arm. And so remember, we have this square drive here, and the arm is going to be coming out like that, and the arm needs to connect to those holes. So we need kind of almost like built-in little like washers is how you can think of it, for the machine bolts to pass through to attach to this platter. However, to do that, we're going to need to create this preserve geometry. And so it's going to be a new body, and they're going to be the kind of, what I call is little feet. And so there's going to be one over each of these holes. And so let's go ahead and let's create a sketch on the top surface of here. So this is a new sketch. We're going to choose that top surface. And let's go ahead and let's look at this top right circle. And what we're going to do is we're going to hit P, so that way we can grab that edge. So P on our keyboard. And if we click that circle, we're going to create a projection link. Projection link also just means that it's going to update if we change that in the future. And so now we've got that circle, we've got the center of it, and what we're going to do is create the foot. And so to do that, we're going to hit our circle tool, start at the center, and we're going to go out. So we're going to go out an arbitrary amount. Doesn't really matter how far, but what we're going to do is define it as a distance from the edge of this circle. So let's say we want it to be 3 millimeters in radius from the edge of that hole, just to give it, you know, some heft. And so to do that, if you try clicking D and doing this, that is going to give us exactly the distance we want. And so we're going to hit 3. There we go. And now we've got that circle. Finish our sketch. We're going to look at it, and we are going to go ahead and extrude it upward. So let's go ahead, hit extrude. And we're going to hover over this, select it, and we're going to extrude it up. Now, it's going to default to joining it because it's touching this bottom platter, but we don't want to do that. We want to create a new body. And we're going to extrude it up 2 millimeters. And let's go ahead and hit OK. So now we've got kind of one of those little feet, but let's give it a little bit of distance off of the top. And so to do that, we're just going to extrude off of the top of this surface. So let's create a sketch, click on there. And again, we're going to project that inner circle. However, let's project this one, which is the top of the platter, not the top of this. There we go. We're going to hit OK. And let's go back to our top plane. There we go. And so now we've got that circle there. We're going to go ahead and we're going to create this 1 millimeter from that circle. So we're going to create an arbitrary circle. We're going to dimension it 1 millimeter. There we go. Finish our sketch. And now we can click that, hit E on our keyboard to extrude this up 3 millimeters. And we set that, if we go back, we set that to join by automatic. It automatically did that. It's going to join it with the body it's already touching. So we're going to hit OK. So now let's zoom out and look around. We've got one object, which is the square drive, which is kind of combined with this little platter, plate thing you want to call it. And then we've got this body 2, which is what I'm calling the foot. And so let's go ahead, let's rename that by double clicking. We're going to type in foot 1, because that is our first one. And let's go ahead, actually we'll just call it foot, because I think when we pattern this, it'll give it numbers. And we're going to create a pattern so that there's 4 of those, and we're just going to do a circular pattern. So let's go to modify, and, oh, sorry, my mistake, create, and then we're going to do the pattern tool, and we're going to do a circular pattern. And we are doing the type is the body, and then we're going to revolve it around the y-axis. So we're going to hit select, and we're going to click that y-axis, and you can see it's defaulting to 3. We're going to make that 4. We're going to hit OK. There we go. So now we've got each of the feet as different bodies. And so those are our preserves. We want the arm of the crank to kind of, remember thinking of it like vines growing, we want it to kind of grow into those so they're connected. Those are part of the preserve geometry. And so those, our bolts are going to kind of run down through those. These are probably going to be clearance, so that's why they're 3 millimeters. And then we would probably thread in this platter right here, so that way the bolts can kind of bite into the plate. So there we are. We've created the feet. And now the next thing is we are going to create the spindle for the crank. So that is the spindle inside the handle that we are going to turn on the crank. And so to do that, we're going to lift it off this surface a little bit. And so we're going to go ahead and look at our front plane. When we draw this, we want it to be probably 5 millimeters or so from that surface. So we're just going to use kind of a different method of doing that. We're going to create a construction plane. We're going to do an offset plane, which is just the default, and we're going to do it from that top surface. And we said 5 millimeters. And so now we've got just another little plane floating in space right there. And you can see it's kind of floating above that if we're looking from the front plane. So let's go ahead and let's create a sketch on this front plane. So we're going to hit the Create Sketch button, and we're going to choose the front plane, which is XY. And let's go ahead and let's project in that offset plane we created. So we're going to hit P on our keyboard. We're going to click that button. And we're going to hit OK, or not click that button, we're going to click that plane. And so now you can see it's just kind of in there. And we're just going to use this as a reference. And so for that reference, we also are going to, let me move over. We're going to imagine the crank is right here. And let's say we wanted to have a radius of 200 millimeters. So from the square drive, a radius of 200 millimeters. So let's go ahead and let's create a construction line. And we're going to hit X on our keyboard before we draw. And we're going to make this 200 millimeters long. So that is our radius right there. Then we're going to need to go up because we want this to be at the same height. And so to do that, we're going to go up like that until it snaps, and you can see we get that kind of this blue line right there, which is showing that we're at the same height as that, which is great. And we can double check that that actually worked. Oh shoot, it didn't. So to create kind of a construction constraint to make sure that it's locked in there, we're going to hit L on our keyboard, and we're just going to create a construction line to there, and then we're going to make sure that that is stuck at horizontal. There we go. So now you can see this is 5 millimeters above that top surface where the bolts are, and this is 200 millimeters away from the center of the square drive. And so that is our 200 millimeter radius for that platter. Okay. So what we're going to do is create this spindle for the handle. And so oftentimes cranks will have kind of a free-floating handle, which allows your hand to kind of pivot around that crank, and that's because as you're rotating it, it's going to kind of rotate relative to your hand as you're orbiting the center of the drive. So we're going to create a round spindle, and so to do that, we're going to create a revolve, and we're going to revolve this profile. And so let's go ahead and create a line, and we're going to turn off construction, and we're going to, let's say that this spindle for the handle is 100 millimeters long. And so we're going to go up 100 millimeters. Great. Now, let's move that dimension out of the way. Now, we are going to create the rest of the revolve. Let's say that the spindle diameter is 10 millimeters. And so if it's a diameter, then we're going to need a 5 millimeter radius. And so we're going to hit line, and we're going to move over 5 millimeters. There we go. And then let's go ahead and move that out of the way. We're going to zoom in up here. Oftentimes, if we're using, like, let's say an ABS handle around a stainless steel spindle, for example, the spindle will have a little groove in it with the handle having a little plastic nub that kind of snaps on over it. That can be created using injection molding or whatever process. But we're going to create that little groove. And this is all part of the preserved geometry for that spindle. And the spindle is kind of attached to the crank arm. And so let's go ahead and let's move to our line tool by clicking L. And we're going to go down 5 millimeters. And we're going to click, and then we are going to create that notch, and let's say it's 1 millimeter deep, so we're going to hit 1. We're going to make sure that that is nice and perpendicular, and then let's make sure that we've got some room for that notch to kind of wiggle a little bit if we need to, so we're going to make that 1.5, and then we're going to go back over, and you can see that that's actually a little overdrawn, which is fine. So let's go ahead, let's hit that check mark, and we're going to make sure that this is the correct distance because that dimension is right there, and you can see that this does not have a distance. So to do that, we're going to go to the vertical constraint, and we're going to click this dot and this dot right there, and you can see that they are now vertical compared to each other. Then we are going to go ahead and go all the way down. So let's go ahead, get our line tool, grab that point, and then we're going to go all the way down. And we're going to, let's say we drew it over a little bit, which is perfectly fine. And let's hit escape. So now, we've drawn it over a little bit, that's fine. Let's go ahead and let's close this. And we're going to use the trim tool, which is by clicking T on our keyboard. And you can see it highlights red, where we're going to erase that little bit. There we go. Then let's go ahead and let's say we also wanted that notch. Oops, I used the wrong orbit. And we are doing this on the front plane. There it is. Let's say we also wanted that notch down at the bottom of this handle. So it's got 2 notches. So that way we're making sure this plastic handle is not going to fall off this spindle. And so to do that, we can just kind of mirror that geometry. And so to do that, let's create a midpoint line along the midpoint of this line. Just like that. And we don't want it to be an actual sketch line, so we are going to click that line and hit X, and that will switch it to a construction line, and then we are going to zoom in here. We're going to select, by holding Shift, those 3 lines, and you can see they're highlighted blue. Then we are going to mirror that across this line, and you're going to see it's going to show, oops, this is actually a good example. We accidentally selected that line as something we are mirroring. We don't want to mirror that. So let's undo. We're going to zoom in here, reselect those by holding Shift, create our mirror, which you can go down to here or it's at the top. And then we're going to select the gatherer for our mirror line. This is our mirror line, and then we are going to look and see a little preview of it down there. We hit OK, and then we can trim this just like that. There we go. And so now we can finish the geometry, and we are going to revolve this. So we're going to go to the Revolve tool, and we are going to revolve it around this axis right there, 360 degrees, and we're going to create a new body. There we go. And so now we've got this new body, which we are going to rename the, we can rename it spindle, or I guess you could call it almost like a pin. So let's call it the handle pin. Cool. So we've got our handle pin, and you can see that that is kind of the radius that we wanted, which was 200 millimeters away. And let's go ahead and when you're putting the handle on to this pin, you want it to be easy to get on. And so to do that, we're going to go ahead and just chamfer this top edge. We can go up to the modify and hit chamfer, hit that edge, equal distance, and let's go ahead and let's chamfer it 1 millimeter. Whoops, I deleted the decimal. There we go, 1 millimeter. So just a little chamfer on there. There we go. So the next thing we're going to do is create the handle itself. And so let's say that this is a stock handle that we have just laying around that we're going to be putting on there, or maybe it's a custom handle that we're going to 3D print or whatever. We can either create the handle itself, or since we are dealing with this handle, since it's what we're going to grab and we don't want any of the generative design to kind of grow outside of this body, we can just create that handle as an obstacle geometry, because we don't want any of the arm to be in there. And so we're just going to create a super simple obstacle geometry. And so let's go ahead and we are going to create a new sketch in the front plane, which we were already looking at. That's okay. And we are going to go ahead and project this edge in there. So we're going to hit P on our keyboard. We're going to click that edge. We're going to hit OK, and now it's in there. Then let's go ahead and project in the top edge as well. So we're going to hit P on our keyboard, grab that top edge, and hit OK. So now we can create a midpoint line to revolve this around. And so let's go ahead and we're going to do that with a construction line. So we're going to turn on construction, hit line, and we're going to go to the midpoint there. And we are just going to go all the way up to there and snap it in. There we go. So now we've got that line in there, and let's go ahead and create this with just a little bit of an offset. So let's create it with 0.5 millimeter offset. So we're going to go up by 0.5 millimeters. And then this is where we're going to start creating that handle preserved geometry. And so we're just going to make it really big and blocky. It's not going to be pretty. It's going to be strictly for obstructing the growth in the regenerative design. So we don't want any of the software to think that it can kind of grow up into that handle, because that is going to be where the plastic is. And that growth is all the arm that we're going to create with the generative design, and we're going to manufacture it, maybe do some laser sintering or something, who knows. But I'm assuming it's going to be metal. And let's go ahead and we're going to turn off construction. We're going to start a line. And let's go ahead and we're just going to go up, let's say, let's be gracious and, or not gracious, but generous and hit 10 millimeters. And then we'll go over, doesn't really matter, enough that, would gather basically the whole handle. Actually, let's go ahead and undo that line. And we're going to go over a little bit more. Let's say 25 millimeters just to be safe. There we go. And then we're going to go ahead and go down. And then let's finish that. And then we say we want the same 0.5 millimeter offset. So we're going to do the construction line, and we'll go 0.5 millimeters. Hit OK, but we need to actually type in 0.5. We're going to hit D on our keyboard, 0.5, perfect. And then we are going to create this line. We're going to connect it to that point. And we don't want there to be construction, so we're going to click on it, hit X on our keyboard, and then we're going to constrain this to horizontal. Perfect. And then the last thing we need to do is go up and reconnect to where we started. So we're going to hit L on our keyboard, connect there, and you can see we're still doing construction lines, so let's fix that. There we go. L on our keyboard, and we are going to go up. Let's keep it perpendicular, and we're just going to connect to there, and let's go ahead and let's constrain this to be horizontal, and that to vertical. There we go. So we have created this, and you're going to see we're going to revolve it around, and that's just going to be this big chunky handle that is going to be an obstruction geometry. So none of the generative design will grow into it, which is good because we don't want it to think that it can grow in there, because that's where our handle's going to go. And so let's go ahead, let's revolve this around. It's defaulting to the last thing we drew. Let's grab that axis, which is that construction line right there, and hit OK. And so that is a new body, which is this one, and we're going to just call it the handle. So we've got the handle, and it is revolved around the handle pin, which is right in there. And we are going to go ahead and create, or we are going to hide the handle just so we can see a little bit more what we're doing. Then the last thing we're going to do is we're going to create the kind of upper and lower bounds of where we want this to grow. Because remember, we kind of want it to grow like that. We don't want it to grow into the bottom here because we've got that the plate that this square drive is going through. And we don't want it to grow up, because if it grows up here, you can imagine our hand is on this handle, and as we're cranking it, then we would hit it if it were growing up into here, because your arm, like the human operator's arm, is going to be on that crank, and you could hit it right there. So we need to create two kind of obstacle geometries, and we want to make these just super simple. So one of them is going to be a nice easy square, and the other is going to be a cylinder. So let's go ahead, go back to our isometric view, and we can turn off that construction plane right there by going to construction, turning off that plane, because it's just getting in the way now. And let's go ahead and create that plate. So like, let's say this machine is in a box or something. This is the edge of that box. And we're going to create a sketch on the bottom plane. And we are going to do it as a center square. But it doesn't really matter. We're just going to make it completely arbitrary. So center rectangle, sorry. And we just want to make it enough that it is outside the handle. Because it's not going to grow anything out past it, because that's just going to be excess geometry. That's not going to be helpful. It's just going to add weight. So this is just enough that it's not going to grow down anywhere. So we're just going to finish that sketch. We're going to keep it unconstrained. It's completely arbitrary. And then we're going to extrude it up. And again, we don't want to make this a permanent distance. We're not going to define it because we want this to update. We're going to change this to object and select this face right there. And we don't want it to erase that because we're creating this as a new object. So we're going to go ahead, change the operation to new body, hit OK, and you can see it didn't affect that that square drive at all. And we're just going to call this the plate. There you go. And if we look from the front, you can see that it's, a perfect join. It doesn't really matter because this is just setting up a restriction. We don't want the crank to go in there, or the crank arm. Cool. And then the last thing is we are going to create another arbitrary sketch from the front because it's going to be in revolve. And this is where our arm is going to have clearance, because if this grows, it's going from here and it grows up like this. If it's up in here where our hand is holding onto this handle, our arm, like our ulna or something, is going to bash right into that. It's going to hurt. So we want to keep this nice and restricted into like a nice tight area right here. So let's create a sketch, and let's turn on the handle again. There we go. And let's create a sketch on the front plane. And remember, we can click and hold to make sure we're choosing the XY plane. There we go. And this is going to be just a nice arbitrary sketch. So let's create a construction line going up from the center. We're going to hit OK. And then we're going to turn off construction. And we are going to go all the way over to the handle to make sure that we are kind of protecting everything. There we go, and let's go ahead, let's make that horizontal. And we can just, since this is arbitrary, we're not defining anything, we can just kind of drag this down until it's pretty close. It doesn't have to be perfect. But basically, we are now going to revolve this. If we hit finish sketch, and revolve the axis, let's cancel that just to make sure we're doing this correctly. That's our profile. The axis is there. We're not cutting. We're going to make a new body. Hit OK. In this body, we're going to call the arm clearance because we don't want to hit our arm. So that is clearance for our arm. And if we look from the front, basically we can see, let's turn off the handle, that it's going to grow down and it's going to be stuck in between these two because we're going to set them as obstacle geometries. And it's going to connect to these little feet. And that is the basic setup of all the bodies we need. Okay, so now that we have created all of the bodies, what we're going to do is first save our design. So let's go ahead, we're going to save this and we're going to call it crank tutorial or something like that. We're going to hit save. So now that is saved, and you can see Fusion versions. So now we're in version 1. And we've created all of our obstacle geometries. However, there are a few more that we need to think about. And that is if we hide this arm clearance. These are kind of the standoffs, remember, for the bolts which are going through. So the bolt is going to come down and it's going to insert into here. And this plate would probably be threaded or something like that. We presumed M3. But that means there's going to be a head of the bolt, which we need to make sure has clearance. However, instead of modeling that and modeling those threads and everything like that, we're going to use something that's called a primitive. And primitives are something that we can create in just the generative design environment. So they're not actually part of the model or anything like that. They're just kind of in this little subsection in the generative design, which is pretty neat. So let's go ahead, let's turn back on the arm clearance and the handle, and let's go back to our home view so we can see everything like that. And now we're going to go into the generative design. So to do that, we're going to change our design workspace right here from design to generative design. And so now we are looking at the generative design workspace. And you can see we are now in load case 1. What we're going to do is we're going to try and think of different situations, different cases that this crank could experience. So for example, it could experience someone doing a regular old cranking. Or it could experience like us putting the handle on. Like let's say we forgot to put the handle on, and so we're putting it on while the crank is attached or something like that. Or maybe taking the handle off. something along those lines, or maybe cranking backwards. So we're going to think about these different situations, and each of those is going to be a different load case. And so those can be complicated. You can have different forces in each load case. You can have multiple, you can have just one, just a bunch of different things. And so what we're going to do in the generative design workspace, and you might have this guide open, this learning panel over here when you first start. That is a really great way for you to step through it if you're not following along with this video, but since you are, you can go ahead and close that and follow along with what I'm doing. So we are creating a new study already, so we don't need to click this new study button. You can see that's a new generative design study. We don't need to do that because we are currently working in study 1. We can go ahead and we can change the study settings. I usually just leave these at default. This is kind of how fine or coarse it does the finite element analysis for the force calculations and whatnot. I like to leave it at default. If we're working on something really small or we want like really fine stuff, we could turn it up a little bit. So let's just do it just a tiny bit. And we're gonna hit OK. So when we're working generative design, basically we're gonna work left to right along the ribbon. And so the very first thing we're going to do is create those primitives that I told you about, which are going to be stand-ins for the bolt heads and the shafts. So let's go ahead and we're going to click on Edit Model. And when we do so, you're going to see we are now in this kind of simplified design workspace. And you can see we have a connector obstacle. And that connector obstacle, if we look in this little image right here, it says it creates an obstacle geometry bodies in locations of bolts or pins in an assembly. We can customize the size and shape of connector obstacles by adjusting the shaft length and diameter and distance for bolt heads, nuts, and tooling. That is exactly what we want. So let's go ahead and let's drop down the model components and the bodies, and let's turn off the arm clearance just so we can see this. And let's go ahead and we're going to click connector obstacle. So it's going to ask us, and let's also turn off the plate. It's going to ask us for the start of the shaft and the end of the shaft. So let's go ahead and we're going to choose the start of the shaft as this hole right there, and you can see it's kind of creating it right now. And we're going to do the end of the shaft as the bottom edge of that hole. So you can see it's just got a pin in there. But because we're making a bolt, let's check bolt head, and you can see it's creating a bolt head right here. So let's go ahead and let's make it maybe 3 millimeters tall and, oh, what the heck, we'll say 6 millimeters in diameter. And that's just to give us room for the bolt head. And we can also create tool clearance if we want as well. So that's for like our screwdriver coming down in there. And for the screwdriver, I mean, we can just kind of make that a little bit thinner. So there is our bolt. And we don't need to worry about the back side of it because the plate is going to be back there, and so that will be our obstacle geometry. But we've got the bolt head. If you wanted to do it on both sides, you can, but we're not, since it's kind of threading into it, the plate. It's not using a nut on the other side. So we're going to hit OK, and we're going to remember 3, 10, 6, 3, 5, 9. Actually, I'm going to write that down. 3, 10, 6, 3, and 5, 9. And we're going to hit OK. And now we're going to do that again. And we are going to start the shaft there, end the shaft there. We're going to do a bolt head. And we actually don't need to remember the 310 because that's just defined by the choosing the geometries. And then we're going to do 6, 3, and then we're going to do tool clearance. It's 5 and 9. There we go. And I'm going to go ahead and do that 2 more times. Okay. Now I've created the 4 bolts with their little tool clearance, and you can see we've actually got those bodies here. So we can see we've got body 10, which is bolt 1, we've got body 11, which is bolt 2, body 12, and body 13. We can rename those if we want, so we're going to call that bolt 1, bolt 2, bolt 3, bolt 4. So we've got our 4 bolts, and remember that you can see those are going through. So we've got the threads going through right there, we've got the head of the bolt, and then we've got the kind of the screwdriver right there. And remember, we're just creating anywhere where we don't want Fusion to grow the generative design in. So we're gonna go ahead and do finish editing model. There we go, and it defaulted those to preserve geometries, which is why they're red. And that's great because that's what we were going to do anyways. So let's go ahead and let's do the rest of our preserved geometries. And so we're going to, obstacle geometries, I misspoke. So we've already got those selected, and let's drop open the model components and turn on the plate and the arm clearance. So our handle is going to be one, our arm clearance is going to be another, our plate is going to be one, and then down in here, our little square drive is going to be in one. So we should have 8 bodies, and you can see they're all red because we don't want it to grow into there. However, now we're going to do our preserve geometries, which are going to turn into green. So we're going to hit preserve, and we should be selecting 5 preserve geometries, and those are going to be each of the little feet and the pin. So we're going to do the handle pin, and then each of these little feet. We're going to hit OK, and you're going to see that those are now green. And let me move that out of the way of the camera. There we go. We've got green right there. So we've got all of our geometries, and we can turn on the plate and the arm clearance. We've got all of our geometries, and those are all defined as either preserve or obstacle. Now, as we move along the ribbon, left to right, our next thing is setting up structural constraints. And so if we read here, it's saying we can set up a fixed pin frictionless constraint to the selected geometry. And they can be assigned to multiple objects, but they have to be assigned to preserved geometries, which is really important. So we're going to go ahead and let's zoom in here, and we're going to hit structural constraints. And let's hide these bolts while we're at it. There we go. And what we're going to do is just define these as being fixed. So each of these are going to be fixed, and that is going to basically create the kind of fixed location of where these are getting bolted in. So let's do that. We're going to do that by choosing a face, and you can see because we've got the type here. And let's actually hide the square drive, and we're going to do this on the bottom sides of these. There we go. So those are sandwiched on in there. Okay, and now we are going to do our structural loads. And remember, these are all kind of appearing in load case 1. So we just did our constraints right there in load case 1. But before we do our loads, remember we were talking about doing different load cases. We want to imagine like different situations, which we talked about, like cranking forwards or backwards, putting the handle on, whatever it may be. And each of those are going to be our load cases. We don't want to have to rebuild the constraints every single time, and so to do that, we're just going to clone the load case. But first, this is the gravity force. Let's go ahead and turn that off because we don't really care about it. Oops, my mistake. We're going to go into loads and uncheck gravity. There we go. And now we are going to create our extra load cases. So we're going to clone load case 1. Clone it again, and just to be safe, let's clone it one more time. So we've got 4. We might not need them all, we'll see. Let's go ahead, and we're still in load case 1. You can see it's activated with that button right there. And let's put our first force as kind of plopping the handle onto there. So let's say we're going to do a structural load, and it's just going to be a force, and we're going to put it on the top of the pin, and let's go ahead and we're going to do this as pounds force. Let's do 10 pounds force. We're going to hit OK, and so now we've got that force there. And then let's go ahead, we're going to do our load case 2, so we're going to activate that, and you can see our first load disappeared because that was in load case 1. But we're in load case 2, so we're going to add another force, and let's say it's taking the handle off. Whoops, we clicked the edge instead of the face. So we're going to do pounds force, and let's say it's negative, let's say it's 30 pounds force to take it off. And we're going to hit OK. And then we are going to do our third load case. And this is going to be our main cranking motion. So let's say our main cranking motion, maybe this is a ratcheting thing, whatever it may be, but our main forward cranking motion, let's say, is pretty strong. So we're going to go ahead and do a structural load, and we're going to do it on this edge right there. And oh, look at that, it's doing it perfectly perpendicular already for us. That's really nice. And we're going to do this as pounds force, and let's make it 200 pounds. And then let's go ahead and let's do our backwards force as well. And we're going to do that in load case 4. And load case 4 is going to have that backwards force. And let's do that here. And we're going to do, as instead of 200, let's say negative 50 pounds force. So now it's going the other direction. We're going to hit OK. So now we've got our 4 load cases. Great. Now we're going to go ahead and go to our next button, which is objectives. And our objectives, let's say it's minimize mass. And this is our goal for the safety factor. Let's go ahead and we'll do 1.5 for our safety factor, or maybe 2. Why not? We'll just leave it at default. And remember, each of these load cases are different situations. So if we had multiple forces, so like let's say that we were wanting to, like the handle wasn't free spinning on this spindle, then maybe we would have a torque kind of on that handle or that spindle as well. So then each of those situations, maybe we would add a torque as another force. We just happen to set it up where each load case has just one force, but you can have multiple forces in each load case, which is great. But when it computes this, what it's going to do is it's going to compute them as each of those load cases could be applying to the final body it's going to create. And remember, it's generative, so it's going to create a bunch of generations of the final body, but each of those should be a solution for each of the load cases. So the final solution should be a solution for all of the load cases, in theory. So now we're going to go over to manufacturing, and let's say the pieces for the volume is more for calculation of cost, which is only for some of the materials in here. We don't really need to worry about that, so we're just going to leave it there. And we are going to do, we're going to turn off milling, and let's say we're just doing unrestricted and additive. And we can turn on all the orientations for additive. Let's say it's like some super fancy, I don't know, laser sintering or something like that. Minimum thickness, let's go ahead, let's bring that down to 2 millimeters or something. These are just kind of arbitrary, we're just kind of playing around. But unrestricted is basically just like fully free form, kind of almost abstract. And then we're going to go ahead, hit OK. So we've defined our manufacturing methods, and now we have our materials. So study materials, if you've ever played with materials in Fusion, you have to kind of drag them to the bodies. This is not requiring that. All we need to do is just put a bunch of different materials into the study, and we're going to define them for all methods, and it will use those. So let's go ahead and let's go to the additive library, and let's open up some metal. And let's do a 304 stainless steel. We're just going to drag it up there, and let's we've already got the aluminum. Let's go to the regular Fusion library. We'll go to plastic, and we'll just try like a generic ABS plastic, and we'll add it up there as well. And you can see it's got like the cost estimation icon right there. Probably not going to be necessary for us, but whatever. We're going to go ahead and we're going to hit close. So we've got our materials selected. And then we are going to look at the pre-check. And the pre-check says, warning, some bodies or components are hidden. If they're assigned obstacle preserve or starting shape geometry, they still participate in the outcome generation. To exclude bodies from the generation, remove them in the edit model workspace, or don't assign a geometry type to them. But it's just talking about the handle, the plate, and the arm clearance, which we already all defined them all. And so that's all we need to do. Next, you can do the previewer if you want, which will just kind of show you like an estimation of what it might look like. It can be a little bit laggy, so we're just going to ignore it. What we're going to do is then generate the results. And so we're going to click on generate. And you're going to see it's going to say it costs 25 cloud credits. This is why it is important for you to be in your education account, because education account is what shows Fusion that you have unlimited cloud credits, so we don't have to worry about the cost of the cloud credits. And if like in the future you're working with a company or something like that, cloud credits cost 25 to just generate the design, and then it costs 100 to kind of extract those generations from the results. So all we're going to do is click Generate Study. There we go. It's going to pop up this little window. It's going to show us the status. The status is going to be sending, and then it's going to take a pretty long time to calculate. So you may have to do this overnight, go eat lunch, whatever it may be, and then you're going to come back. And one other thing to point out, though, is that while it's generating, you may see little previews popping up behind here. Those are explorable if you want, but you have to wait until the entire thing is done, and then you'll be able to see your final results. All right, so we've let this run for a few minutes, and you can see it still says it's solving, but it's generating outcomes in the background. And I've run multiple studies. You can create as many studies as you want and do different situations with them, as I said. However, we can start to pull out models that we like before it actually finishes. So for example, if I really like some of the things that it's already creating and you can see it's still thinking, I can go ahead and take some of those. So for example, it's going to give us some recommended outcomes and we can look at them. So for example, let's look at outcome 15. In outcome 15, you can see we get a preview of what it'll look like. It's showing it in, it looks like aluminum, which we can see over here. And we can orbit around, check it out, and examine the structure that it thinks will solve that solution. And if we want, we can turn on the preserve geometry. Let's zoom out a little bit, look from an orthographic view, and you can see how it's actually growing that structure into there. We can finish this and look at other ones. For example, looks like 12 might be interesting. And you can see information over here on the right that's relevant to your design. I'm really liking how this one looks just based off of the first glances. You can see it's got a really nice organic shape and it's relatively symmetrical, which is nice as well. We might want to modify this and make it perfectly symmetrical. However, remember we talked about having that crank stronger in one direction, a little bit less strong in the other direction, and that's probably why this isn't perfectly symmetrical. However, you can see that this is a really neat organic design, and that might be something that I end up 3D printing. We can also compare, and this is a really good function. For example, let's say I wanted to compare study 8 and, oh, I don't know, 12. So I could click on 8, click compare, and click 12, and it's going to show both of them side by side, and it's going to orbit both of them. And we can look at study 8 as we zoom in on the head here. It actually is only using 2 of those feet. It's not using these 2 over here, which is interesting. Or it's minimally using them, I should say. And so that might be something where we realize, oh, maybe we don't need those 2. But we can orbit both of them in the exact same time to kind of inspect them. Another thing you can notice right here on study 12 is this one is not actually perfect. It's got some growth inside here, and that may be because of the clearance we left for sliding the handle on, and it was like, hey, I'm going to grow in there. We would actually need to clean that up, and that you can do simply with just using the unite function or the union function and removing that. Yeah, so let's say that this is the one that I want to import into my design. So I'm inspecting it, all the information looks good. What I'm going to do is I'm going to click one of these 2 buttons for create, and I can create a design from the outcome, or I can create a mesh design from the outcome. And a mesh design is usually something that is used more for organic modeling. Might be something you may be familiar with, Blender, for example, or anything like that. But using the design is probably going to be more useful for most of our cases. So we can click that button, and you're going to see it's going to talk about like the cost and such. It's going to open it as a separate tab, and it can take a few minutes. If we check this box, we can see our cloud credits and how much will remain. So we have many cloud credits, and afterward it just has a hyphen because it doesn't cost us anything, and that is because we are logged in with our educational account, and that's why it's really important to log in with the educational account. So if this is the one that I want, and I think it is, I'm going to go ahead and click Create Design, and it's going to take some time because it needs to create that design from the cloud. So it's going to do that, and we're just going to let it think. Okay, so after a few minutes, it has finished processing the outcome, and you can see here there's a button to open the design. So I'm going to go ahead and click that, and we're going to wait a moment while it's just calculating, and it's going to create this in a fully new file. Okay, and there we go. You can see that we have now opened this up in its very own design, and you can see it actually takes the timeline, and it is an editable timeline. So you can go through, edit it how it created it, and then we can fully customize this. So if I wanted to make this perfectly symmetrical, if we look from the top, you can see it's not quite symmetrical, but it's pretty close. If we wanted to make it perfectly symmetrical, we could. If I wanted to clean up this edge right here, that would be perfectly acceptable. All these things, and then we can go ahead and use this in whichever ways we deem necessary. So that has been the tutorial for generative design in Fusion. This is a really neat form of computational optimization, and I hope that you enjoyed it and find it useful. Thanks, and have a great one.